Okay, so we can start slowly. Welcome to the EU Road Safety Cluster webinar, introducing innovations for road safety in complex urban environments. My name is Andrea Lopes Azevedo. I'm from Polis Network, and I will be the moderator today. Okay, so as a cluster, Soteria, Phoebe, AI for CCAM, Haiti, Frodo, and Events, they come together with a mission for a shared vision for establishing the safe system approach. The projects have different focuses, but, but they aim at enhancing urban safety of our users, including pedestrians, cyclists, micromobility users, children, elderly, and on a more complex environment and mobility systems that we are today. The projects look at predictive analysis, behavior simulations, artificial intelligence, human-machine interfaces, CCAM, and much more. So we try to organize the short presentations today, covering these different topics, departing from projects with a stronger focus on vulnerable road users and proposing new frameworks for road safety, and moving to the future of safe and reliable AI and automated mobility. So we will have short presentations of the projects, as you can see on the screen. And after that, we're going to have an open discussion with time for some Q&A. So please send your questions on the chat and the Q&A box, and we will go over them later on. So let's not take much longer. Let's take a look at the projects and their approaches and have a glimpse of how these approaches, they're complementary and they come together to increase the safety of our mobility systems and users. So let's start with Soteria. Antonio, if you want to share your screen and start your presentation.
Can you hear me, right?
Yes, we can.
Okay, I will resume my screen. Okay,
yes.
So let me introduce myself. I'm Antonio David Masegosa from the University of Deusto, and I'm today representing here the Soteria project. Okay, so this will be a very introduction to, let's say, what is one of the challenges that we are trying to solve with Soteria, how we are solving, and I will also let you know what is the current status of the project. Okay, so one of the let me introduce, as I said before, one of the main challenges of the project. So you might be aware of the safety triangle, no? That established that the frequency of unsafe actions or near misses is related to the number of accidents with minor, serious, or severe injuries that we can see in this triangle on the right. And this triangle have the different, let's say, different implications, but one of them is that a location with no reported severe accidents or fatalities is not necessarily a safe location. And what it may happen is like these safe or these unsafe actions or near misses have not materialized yet into accident with injuries. Okay, so in this way, the challenge that we are trying to address in Soteria is to try to identify near misses and unsafe actions that are usually not reported using novel data sources, and then utilize this information to uncover potentially unsafe locations for vulnerable road users, hopefully before the accidents happen. How we are doing this? First, by leveraging, as I mentioned before, novel data sources, and more specifically, connected vehicle data to try to detect harsh vehicles events, like hard braking, sharp turns, or speed ups that can serve as a proxy for these near misses or unsafe action. Actually, as you can see on the right, there is a nice correlation, strong correlation between accident and these harsh events. And also, for example, we are using cell phone and micromobility data to try to identify locations that has a lower or a higher than expected ratio of accidents per circulating vehicle, because it can tell us if there are maybe some external factors that are influencing this higher or lower risk than expected. And apart from that, we are also developing two different types of approaches. One, let's say, based on classical techniques like generalized linear models, but also another one based on artificial intelligence, and more specifically on deep learning, to try to estimate accident risk at network level. That is, try to estimate accident risk in a predefined area for all the sections and for all the road sections and intersections. And in this way, hopefully, we will uncover this potentially unsafe location for vulnerable road use. So at this stage of the project, we have already released the first version of the Soteria solutions. So we also performed the first phase of the testing of the solution in the previous year. And then the next milestone that we expect to achieve are the release of the refined and improved solutions that we are developing in Soteria, that we expect to achieve by October of this year. And then in March 2026, hopefully we will have the results of the final testing phase for these solutions. So if you are interested in knowing more about what we are developing and what we are doing in Soteria, please follow us in social media and also in our website. So that's from my side.
Thank you, Antonio. So now let's go to James and Phoebe.
Hi there, everybody. I'll just bring up my screen. Yep, the Phoebe project that we are involved with is, of course, a partnership between a number of different organisations all across Europe. What we're doing is we're coming together around three specific use cases, so Valencia, West Midlands and Athens. And within these, the challenge that we're trying to solve is to look at a traditional city like this and understand how can we actually integrate different data together and different approaches to actually understand road safety, flows, and other stuff correctly. So one of the contexts is that you will get crashes dotted around the network, but of course, those kind of data don't necessarily give us the full context of it. So what we want to do is utilize micro simulation models to understand exactly where the movement is on the network and how it's all interrelated. Then as part of that, we'll then put on the demand, so what the different flows are for the different user groups. So this might be vehicle flow, motorcycle flow, pedestrian or bicycle flow. Then on top of that, we'll then also create these IRAP star ratings. So this will give us the level of risk per individual road users, whether that's a vehicle occupant, pedestrian, motorcyclist, or bicyclist. From that, we will then link those two networks together, both the micro simulation and the star ratings, to provide that really good alignment so that you can actually, as you change things in terms of the micro simulation model, it can then re-update the star ratings and see how that changes. Then on top of that, we'll then put in a level of user behavior to understand what kind of levels of compliance are on the network. And then ultimately, we will solve this problem by actually integrating these different models together. So we've got both demand of where people want to go on the network, what the level of safety is, what the relevant behavior is, and then integrate them all so they actually interact with each other through the micro simulation model. Where we've got to so far is we've actually built that framework so that we can actually understand how the different sections of it integrate. We've refined both and created some of the behavioral modeling, refined the safety modeling, and starting to really integrate those within AIMSA microsimulation. Thank you very much for listening. I'll pass back to you, Andrea.
Thanks, James. So now we go with Arno and AI for CCAM.
Yes, hello, good afternoon, everyone. So my name is Arno Gottlieb. I come from Simula Research Laboratory in Norway, and I'm the coordinator of the AI for CCAM project. And in AI for CCAM, we have adopted an holistic approach of artificial intelligence, where we believe that artificial intelligence systems and models for automated driving shall be safe, robust, transparent, fair. And in order to foster user acceptance of automated driving systems, we strongly believe that it's important to develop methods and tools that can make the systems more transparent, more explainable, accountable, fair, and so on. So we have adopted actually the definition of trustworthy AI, which follows a human-centric approach of AI from the European Commission. And our ambition is to put it on the side of automated driving systems. We've achieved, so the project has started 2 years ago, and we've achieved different things in the project. We initially started with the development of a methodology to integrate trustworthy AI guidelines in automated driving. Then we explore the different scenarios that can be used, including vulnerable road users. And those scenarios, they include ethical issues in automated driving. Then we performed some advances, strong advances, in particular in different aspects of automated driving systems, scene understanding, including relevant object detection, cause understanding, cause analysis of automated driving actions, relevant object detection. We also worked on pedestrian trajectory prediction, multi-pedestrian trajectory prediction and testing. More generally, we've been developing methods and tools for AI safety in automated driving research. We also have a strong focus on user acceptance of automated driving, and we've developed a participatory space that uses methods and tools coming from the participative democracy aspect. And we have just launched this participatory space, which aims to collect opinions of citizens on automated driving, and especially on the usage of AI in automated driving. Eventually, in the project, we develop use cases using simulations and virtual realities. And we've simulated those scenarios, including ethical aspects. And the goal is to collect physiological data from different participants in order to understand what's the level of stress related to ethical issues in some scenarios in urban environment. So the takeaway message, so AI for CCAM is dedicated to trustworthy AI in automated driving systems. We've developed scenarios and simulations with virtual reality involving ethical issues and road users in urban environment. We are performing advances in AI safety and transparency, especially on the side of scene understanding, pedestrian trajectory prediction. And we foster user acceptance of automated driving and AI in automated driving by using participative democracy methods. Thanks a lot. And I encourage you to follow us on the different channels, media channels that we have developed for the project. Thank you.
Thanks a lot, Arno. So now we go with Paolo from Haiti.
Hello, everyone. Good afternoon also from my side. My name is Paulo Preto. I work at Virtual Vehicle. We are the coordinators of the Project Heidi, which stands for Holistic and Adaptive Interface Design for Human Technology Interaction. What's the main problem we are facing that we are addressing in our project? It's essentially the fact that interactions between vehicles and pedestrians are inherently unsafe. And this is mostly due to a lack of mutual understanding On one side, the pedestrian never know whether the car has seen the driver has seen the pedestrian, is the car going to stop or not? And on the other side, the driver is also very often in a distracted state due to large infotainment screens or other non-related activities. So in both cases, for the driver and for the pedestrian, there is no specific account for special needs. Imagine, for example, as I said before, when the driver is distracted or when the pedestrian is an older person walking on crouches and so on. So the challenges we're facing is all around designing non-distracting, useful interfaces that somehow convey information to both sides of the vehicle, the internal side to the driver and the external side to the pedestrian, and that allow us to also investigate the safety, the usability, and the acceptance of whatever solution is being developed, accounting for different user needs, not only walking on crutches for pedestrians, but also what about if there are children? What about if the driver is older and with reduced reaction times and so on? And also for technologies and systems that work from manual, traditionally driven vehicle to automated, fully automated, and even to autonomous vehicles, where a lack of current regulation also steps in. So the solution that we have developed so far, we are now at 2.5 years into the project, or said otherwise 6 months from the end. So we're working toward this, what we call this fluid cooperative interface and logic. So an interface that on both sides, to the driver and to the pedestrian, makes use of multimodal information and that are adaptive to the state of the person that is the recipient of the information, and that is unobtrusive. So you don't perceive that information unless it's necessary. So exemplified on screen, the use of dynamic lights, motion, icons, sounds, and voices, and of course, also from the pedestrian side, dynamic lights and icons. As I mentioned before, we also work in the development of a logics, the logics that somehow takes information from the road, from the vehicle, from the driver side and the pedestrian side, so with internal and external sensing systems, convey the information to these logics that is responsible for understanding, recognizing the potential dangers, the potential situation, predicting the intention of both agents on both sides, resolve the situation, taking into account constraints in terms of safety and in terms of efficiency. Because of course, if the perfectly safe situation is a situation where nobody moves, but that would not be very efficient. So we need to balance the two constraints. And last but not least, of course, is responsible for selecting and showing action recommendation to the driver and informing the pedestrian about the intention and the action of the vehicle, closing the loop, changing the road situation on the road, and keeping track of those changes over time. The results that we have achieved so far that are, let's say, easy to grasp is, first of all, from a research point of view, the build of a co-simulation research tool and environment that different partners in different capacities have implemented at different locations, but it is exemplified here by one of our partners from Sweden. This possibility of having driver and pedestrian acting at the same time and experiment with different interface layouts. We also have running vehicle prototypes with external symbols and dynamic motions, and so external interface for pedestrians. And work that is still going on, that is almost finished in terms of testing human-machine interface for the driver and testing the actual integrated system on a safe road situations. Last but not least, of course, we're also informing and participate into regulatory bodies and standards, especially because we are part of the Euro NCAP working groups on human-machine interaction. Thank you very much.
Thanks, Paolo. Now we go to Elena and Frodo.
Okay. Hello, everyone, for me as well. I'm Elena Maduka. I'm a senior researcher at the National Technical University of Athens, and it is a pleasure to be here today to introduce Frodo. Frodo is a project dedicated to advancing safe, secure, and seamless connectivity and automation in transport. As urban environments become more dynamic, road conditions, traffic patterns, and user behaviors are constantly changing, especially with the integration of SICAM services. At Frodo, our goal is to develop a federated digital twin environment that enables intelligent, real-time connectivity between vehicles, road users, and the infrastructure. By leveraging advanced sensing, AI, and simulation environments, we focus on adapting operational design domains to real-world uncertainties, ensuring a safer and more efficient transportation network. To achieve this, we have adapted and extended the well-established safe system design framework for SICAM services, which consists of 5 core elements: safe vehicles, speeds, roads, post-crash care, and safe road users. Each of these pillars is directly linked to a Frodo component, forming a holistic approach to the safe design of ODDs. To test our solutions, Frodo is conducting 4 pilots, combining lab-based and real-world testings and experiments. These pilots assess state-of-the-art localization sensors, AI-based traffic monitoring and management through microsimulation, and advanced communication protocols to ensure seamless integration and safety. In this early stage of our project, or only on the eighth month of this project, we have 4 key findings that stand out. ODDs must be extended to proactively adapt to real-time challenges and improve situational awareness for individual vehicles. Infrastructure design standards need to be updated for safe interactions in automated environments. Advanced anomaly detection and accurate localization systems are crucial for secure navigation and for ensuring connectivity. And finally, safe interaction standards must be established to ensure privacy for road users and data security. Finally, we present the main expected innovations of our project by addressing the 5 key pillars of the safe system design. And specifically, we leverage vehicle-to-everything communication for situational awareness. We will quantify infrastructure readiness level through a detailed readiness estimation framework. We will develop advanced positioning algorithms to enable accurate speed management and implement state-of-the-art traffic management strategies for traffic monitoring and control in the presence of connected and autonomous vehicles. We will enhance anomaly detection mechanism for crash prevention. And finally, we will improve interaction mechanisms for all road users. If you want to learn more about our project and follow the developments that will take place, you can follow us on social media. Thank you very much. Andrea, back to you.
Thanks, Elena. So last but not least, we have events with Bill. We cannot hear you. I don't know if you're trying to speak.
Yes, can you hear me now?
Yes, now we
Okay.
can.
So hello, I'm Bill Rungas from ICCS, also from NTUA, representing events. We are, as ICCS, the coordinators of the project. We are on our 3rd year, so I will go very briefly to the challenges that we have faced so far. So I'm going to show 3 challenges. One was the challenge to improve the perception in adverse weather, and the solution that one of our partners came up was using 4D radars for perception in adverse weather. Just very briefly to say that 4D radar is like a radar as we know it, but also with the height. So there are sensors not only horizontally but also vertically, so we can get also the height of the objects. And there is an illustration on the right. The second challenge was to be able to augment both the perception and the decision-making using vehicle-to-everything technologies. And we did that by be able to use both collective perception and intention prediction. So on the right, you can see a depiction of how it's shown the collective perception within a roundabout. So we have several vehicles and they communicate either with each other or with a roadside unit, so with the infrastructure. And they are able to exchange information and be able to create a composed image of the whole scene, even if the vehicle cannot see several items that are obscure. So also, along with the perception, we have the decision-making using an intention prediction. Here is an example of that video. Using only an RGB camera, we can be able to predict what, in a motorway, what a vehicle will do. And you can see 3 numbers. They are for the probability of changing lane to the left, changing lane to the right, or keeping the lane. And lastly, the third challenge that we have tackled is the vulnerable road user prediction and planning. And the solution from one of our partners was the development of accurate deep learning-based prediction methods by taking into account class info and map data, being able to transfer models, motion models from other domains. And here's a depiction on the right, being able to accurately predict the intention, the movement of the pedestrian and be able to accordingly plan. So to close, we have faced several hinders, and that it's good, I believe, for everybody to know that adverse weather in real world is quite difficult and very time consuming, because you might have to wait several months to find the appropriate conditions. And also something not technical, but equally, I think, important, is that it's quite difficult to find specialized personnel, even in a junior level, but also in senior. So the work that we're doing now is that we are integrating the control for an end-to-end experiment in a robust way. And we are also have started the rigorous evaluation of the implemented algorithm in order to be able to build a trust for the system. With regard to VRUs, we are aiming on the robustness of the system, and for several, especially when the several VRUs enter the scene and they create a very dynamic behavior. Thank you very much. You can contact me or through our media in the project. Thank you, Andrea. Back to you. Let me stop sharing.
Thanks a lot, Bill. So we're gonna have like a short open discussion now with the speakers. We see a lot of questions already, but feel free to send more our way, and we will try to answer all of them. So I will ask the speakers to turn on their cameras, because we're gonna be talking with one another. We're gonna start with Antonio from Sotera. So Antonio, during your presentation, you mentioned that you're using novel data sources and new techniques to identify locations that may be potentially unsafe for vulnerable road users, even if there's no crashes reported yet there. So, but how will this information be available for the vulnerable road users, for administration, and other stakeholders that have interest in knowing that?
Thank you very much, Andrea. Yeah, actually, as a part of the solution that I mentioned in my presentation, we plan to develop, say, two tools that are related, to how we will expose, show this information to the user. To the users. One will be a mobile app, especially designed for vulnerable road users, and the other one will be a dashboard, more oriented toward this administration, these decision makers, that are related to road safety. For example, regarding this mobile app that I mentioned, the information that I presented before will be used, for example, to warn VRUs or vulnerable road users when they are close to these unsafe locations, and also to suggest them routes that are safer because they pass through roads with a lower accident risk. Okay. And then this dashboard that I mentioned, that were more oriented towards administration, decision makers, or other type of authorities. We are using this data, for example, to display the location of accident hotspots for different type of vulnerable road users, so we can differentiate between cyclists, pedestrians, or motorcyclists, for example. We are also able to show in a map road sections or intersections with a high concentration of harsh events, so that can be potentially unsafe locations. Also combining the different data, we are able to identify, for example, road segments that have a frequency of accidents higher than expected, given the flow of vehicles, or the flow of private vehicles or micromobility vehicles that they have. And then this is something that we already have in the tool, but then in the upcoming months, we also plan to include these predictions that I mentioned before, these predictions of potentially or potential hotspot, or location that can become accident hotspot in the future by using this prediction from artificial intelligence methods.
Great, thank you. So everything will be everything, but people will have ways of accessing it. That's great. James, you talked about the Phoebe framework and how it's already been shaped, but who will benefit from the project, from the Phoebe framework?
So I think it's quite a lot of people, because I think the real genius behind the project is actually it's focusing on providing a framework as opposed to providing working with one single micro simulation tool. So it means that other micro simulation tools can actually look at it and learn and adopt their systems and improve their systems. So ultimately, anybody who's working in an urban environment using a micro simulation model could actually adopt this kind of approach to understand that interaction. So whether that's a city planner or a road safety engineer or a road designer, there's lots and lots of potential. It could even be eventually pushed out and actually used for things like public transport planning. So where are people wanting to move on that networks? Where are people are high risk? And therefore, where should we actually be providing that public transport to reduce the risk to them?
Sorry, thank you, James. So now thinking about AI for CCAM. I know you showed your approach to increasing road safety, and I wanted to know what are the innovations that are being foreseen and developed in the project regarding AI safety and automated driving systems, for example, when the onboard AI system are used in the complex urban environments that we see today.
Thank you so much for the question, Andrea. Yes, AI is a revolution. It's not something new that I'm saying. This is just that in Europe, we want AI to be integrated with some guarantees, some trustworthiness. And we believe it's very important for the user acceptance of automated driving that AI is trustworthy. And in the project in AI for CCAM, we are making innovation on the side of AI safety in particular. I would like to mention 3 examples. One is related to robustness. If for those who are familiar with pedestrian trajectory prediction models, they are inherently non-deterministic. And testing those is quite difficult because the ground truth doesn't help so much to know if those predictions are interesting or totally out of the blue. So in AI for CCAM, we have developed a very advanced testing methodology based on metamorphic testing in order to test those models. The second example is on the side of transparency. We are working on scene understanding. And for those who have been working in this area, you know that it is very important to capture the spatio-temporal relationships on the entities on the road. And if you just stick to the perception systems using AI, you may lose some qualitative relations between those entities. In AI for CCAM, we have developed graphical representation of those spatio-temporal relationships between the entities on the road, including the ego car. And we are using this graph representation, this qualitative graph representation. We are using it for different applications to identify relevant objects on the road. So objects which have an implication on the action of the ego car. We are using it for cause analysis. We are determining the cause of some events. And we are also planning to use it for generating new scenarios. The third example that I would like to mention is related to ethics. And I'm not a specialist at all of ethics, but we have developed scenarios with ethical issues. And in order to test those scenarios, we are using virtual reality and simulation and sensors. And those sensors, they capture some physiological data from the pedestrians in order to evaluate the level of their stress in front of some difficult situation on the road in urban environments. So as you can see, we are looking we are adopting a holistic view of artificial intelligence and trustworthy artificial intelligence, especially on the side of robustness, transparency, ethics, and that's what we are trying to do in terms of innovation on the side of AI in automated driving.
Thanks very much. I know this is very interesting and indeed very needed. And then following the same idea of AI, which Heidi is also looking at, Paolo, what does it mean that the interfaces are adaptive to the user's state and the evolving situation? Maybe you can also give some practical examples of how this would work.
Sure. I can start with a very simple example. I say, so you have a pedestrian that is about to cross the road and a car is approaching, right? And normally there is like an eye contact nowadays, but these eye contact are very unregulated, very subjective, very unreliable, so you never know what is going to happen. So, and even worse will be in the future when the car maybe is more and more automated. So how do you communicate the intention? So how can you recognize the mutual intention, right? So what we have developed is this sort of cooperative interfaces where once the situation is detected where there is a pedestrian that is about to cross, so there is an intention that is predicted, and on the, for example, on the driver's side, there is the system recognizes that the driver is not taking any action, but the best resolution of the situation would be that the driver stops and let the pedestrian pass. Then the system will trigger a warning to the pedestrian. However, if the pedestrian is, for example, in a distracted state, the warning will be different. And it will be, for example, displayed where the pedestrian is looking at, the driver is looking at, supposing that the driver is looking at the infotainment screen, the warning will also appear visually on the infotainment screen. But if the driver is older, then we also have a different warning, because we have seen in our studies that all the drivers prefer verbal prompts. So the warning will say, attention, pedestrian approaching on the right. And if the driver is in an attentive state, there will be a light that dynamically highlights the position of the pedestrian, because that is considered less obtrusive for an attentive driver, and so on. But in all cases, warnings will not be triggered if the system detects that the driver and the pedestrian are acting according to the planned resolution. Also, there is an asymmetry between what happens inside the car and what happens outside of the car. To the pedestrian, we never tell what to do. The pedestrian is only informed about what the car is going to do, which is why from the outside, there are only 3 possible icons that are displayed. There is an eye that simply tells the pedestrian, I've seen you. And in the end, it doesn't matter from the vehicle side if that has been seen by an automated driving system or by a human driver. And then there are, for example, arrows that are dynamically pointing downwards and moving downwards. And that's the signal to say, hey, I'm slowing down, and so please pass. Or pointing upward to say, I'm going to continue my straight. Those are, of course, not something that we are born with in terms of understanding. So there is still need for an explanation, but we found out that that is sufficient to have once the explanation that sticks with the understanding, and there is no need for intensive training or anything like that. And so also one last thing about this adaptivity of the interface to the ever-changing situation over time. So whenever the situation is evolving and the car, for example, is getting closer and closer to the pedestrian, and we see that the driver is not responding to the intended action, then the warning will be escalated and will become more prominent until the automatic system could eventually take over in case the driver decides to never listen and never adopt the recommended set of actions. Thank you.
Thank you very much, Paolo. That's very clarifying. And good that we're looking into ways of adapting. That's good. Now let's go to Frodo. So Elena, how should future ODDs, so the operational design domains, be designed to enhance safety and cooperation with infrastructure? And then maybe just elaborate a little bit, what do you mean by the ODDs?
Okay, Andrea, thank you for this question. So, given the dynamic nature of traffic conditions and the ever-changing road networks and infrastructure, future ODDs should be designed with many redundancies following the fail-safe design. This means that they will allow for increased tolerance to vehicle and context-specific changes, and of course, human errors. This is needed to ensure both safety as well as the seamless cooperation between the vehicle, the physical, and the digital infrastructure. This is a great challenge to achieve because so many players or users coexist on the road, and in the presence of connected and autonomous vehicles, not only users but also data, information, and decision flow should be taken into account and ensure for a seamless cooperation among all these actors.
Thank you, Eleni. And maybe let's go to Bill. How do you see the methods that events are developing for augmenting the perception of the vehicles to be integrated in a full autonomous context?
One of the advantages of the work that we do on the perception part is that it can be work that can work both independently. So even in a fully manual vehicle, it can be used as an aid to the driver, but it can, of course, give inputs to the control of a full autonomous vehicle and be able to provide input for that. And but the important is that they are components that can work both as standalone, but also a part of a full autonomous system. And so that kind of answers this question, I believe. Can I also answer a couple of questions that I saw very quickly on the chat regarding events?
Maybe choose one. I had one. Just choose one, and then we go to
both very shortly. Yeah.
Okay.
So there is one question: are other sensors and/or sensor fusion used in addition to 4D radar? Yes and no. No, I mean in the experiments that we are using 4D radar, we don't use sensor. We only use 4D radar, but we use LiDAR for the evaluation. So we use LiDAR to be able to have not, of course, the ground truth, but a more accurate representation, and in order to be able to evaluate the 4D radar. And then the other one, very quickly also, in the north, adverse weather includes usually bad road conditions. And there is comma included, meaning is it included? Well, when we're talking adverse weather, we're talking either in the perception or in the control part. So the bad road condition, I guess, goes to the control part. And yes, we are including methods, and the algorithms on the control part take into account that it got disappeared. Okay. I think this question was disappeared, but it's okay. But there is adverse weather on the perception. So what do we miss through rain, through snow, through having snow, for example, on the marks on the lanes, or having maybe a drop on the sensor? And then there is how we take into account the slippery road on the control part.
Thanks a lot, Bill. James, one question for Phoebe. With the behavior models, what kinds of parameters are exactly part of those?
Yes, it's brilliant. So what it does is certainly within the star rating, the IRAP star rating, it starts from the context of what is the objects that could cause injury to the pedestrian or the vulnerable road user, and then looks at the dynamics associated with that. So for a pedestrian walking along the sidewalk or footpath, it's very much about a vehicle losing control. So it's things like curvature of the road, the grade of the road, how wide the lanes are, how many lanes there are, how wide the paved shoulders are, and stuff like that. And then, of course, there's all like the likelihood of the vehicle lose control. But then, in terms of the severity of any crash that does happen, it's very much what are the sidewalk facilities? Are they adjacent to the road? Are they separate? Or is the pedestrian even walking in the roadway? And of course, underlying all of that, both of those two, both the speed, the likelihood, and the severity, is the speed, because that's particularly fundamental. Then when you move over across to pedestrians crossing the road, similar kind of dynamics. So it's things like how many lanes are there, how wide are the lanes, the speed, how easy it to recognize if there is a pedestrian crossing there, and features like that.
Great, thank you. And then since we're talking about behavior and movement, I don't know, for AIC CAN, there's a question, because you do mention also predictions of pedestrian movements. And do you feel that this will ever be safe enough to base autonomous vehicular movement, or is pedestrian movement just too unpredictable? And then especially regarding to children. And if anyone else has anything to add to that, please feel free to do so.
Thanks for the great question. So first of all, there is an entire debate on whether we shall consider different types of road users, and for instance, consider different models for those who are older, those who are younger, and so on. And we believe in AI for CCAM that it's very important to measure, to have indicators on whether things are acceptable in terms of ethics or non-acceptable in terms of ethics. I would like also to jump in, if you allow me, to jump into another question that I saw, and thanks also for the great question. for AI for CCAM related to the usage of generative AI or more generally LLMs? I think this is a very general question. So generative AI is coming all over the place, and it is a revolution by itself in artificial intelligence. So we see more and more research activities in developing generative AI instead of traditional AI systems. So this is very important to understand what could be the benefits, what could be the risks of using generative AI within automated driving systems and applications. And we also believe that it's very important to develop trustworthy generative AI, in the sense that, as you all know, generative AI tools can hallucinate, and embedding those hallucinations, those models that can hallucinate in embedded systems, in automated vehicles, is really something that needs to be dealt with. So we need trustworthy AI to be developed also on the side of generative AI. And the European Commission has taken great actions to go into that direction.
Thanks a lot, Arno. Maybe when talking about data, so for Soteria, safety data can be sparse and unbalanced, and does this affect the development of the models, making them a little bit biased? And if there's plans to address this potential issue?
It's actually a very good point, because say my background is in machine learning, and actually we are now working on this, and it's one of the challenges that we are now facing, how to deal with this highly unbalanced characteristics of accident data, because it's very sparse, and then we have very few locations in an urban area, for example, with this accident, and how can make this prediction first accurate, but then let's say also unbiased, because depending on the area, the region, or the characteristics of each this infrastructure in one zone or another, maybe we can find some biases. So the answer is, let's say, two things. So on the one hand, we are applying like a specific AI techniques to deal with this unbalanced character of the accidents, especially accident data. Okay, because it's the one where we are facing more. We are facing, let's say, the most complicated problems. And on the other hand, one of the core parts of the project that I didn't mention is that we will develop, similar to what Arno mentioned, we will also develop explainable AI techniques, especially adapted to try to correct and take into account these bias. Luckily, we have also like a different data that can differentiate, for example, accidents or demand by gender or by age. And the idea is to try to perform different analysis to try to see if we have geographical biases, gender biases, or age biases, to try to avoid them, and hopefully not try to have this trustworthy and human-centric prediction also for Soteria.
Thank you, Antonio. I think that's maybe the approach, of all the projects, since all the projects have this human-centric approach. For the speakers, is there anything else that maybe you would like to share or raise, since we have 6 minutes left?
Yes. If possible, I would like to also answer a couple of questions that came up.
Yes.
One was referring also to this question about the pedestrians and the actual ability to predict pedestrians' intentions and trajectories and so on. And the fact that, yes, it is indeed complex, difficult, challenging. And if we target purely autonomous level 4, level 5 vehicles, that's probably quite beyond state of the art. However, if you consider some sort of partial automation level, or simply some sort of assisted driving, one approach that we're taking in HyDi is to also not look just at what the pedestrian is going to do, but also look at what the driver is going to do. And that gives, of course, some redundancy in the safety. When the algorithm needs to take a decision, what's the best resolution of the situation, as we said. And if we see that the driver is properly reacting to the situation, then we know that most likely the situation is going to end up safe. If we see that the driver is somehow drifting from the expected course of actions, then that's where the interface comes into play to compensate. And that is sort of the concept of fluid interactions that somehow compensate, like the physical metaphor of a fluid, and compensate for motion in different possibilities. The other point that I want to briefly mention, there was another question directly to Heidi in terms of what are going on efforts for standardizations of external HMIs. Well, we know that at least from the Heidi perspective, yes, we are actively engaged in these standardization efforts, and the solution that we have proposed, contrary to many solutions that you can see in showrooms and that only work nicely with a nice wow effect in the showroom, this solution we have developed is something that respects all the current very strict European regulations on external illuminations. So the small, simple icons and moving partners respect all the criteria that are set in terms of positioning, angles, illuminations, visibility, and so on, that they've been carefully measured such that basically such a solution could potentially enter the market with very little effort on top. As I said, contrary to many other solutions where you have even a lot of colors, a lot of animated icons, where, for example, aspects of human visual resolutions or angle of the field of view are not taken into account. Thank you.
Thanks a lot, Paolo.
If I may also, just a
yes.
small point regarding Frodo, because I see some questions in the chat. So I want to clarify that the idea is to extend the ODD in a way that it can adapt easily to the changing of the environment, and to do so we aim to incorporate predictive analytics with a special focus on testing specific urban scenarios related to different traffic conditions, infrastructure setups, complex geometries, and weather conditions. And of course, the aim in Frodo is to investigate and even enhance the cooperation and communication between the vehicle and the physical and digital infrastructure. Okay, thank you.
Thanks a lot, Elena. So I think it's time for us to start wrapping up. Don't forget that we will upload the recording of this webinar on the Phoebe YouTube channel, so feel free to check it out. Please continue to follow the projects and check the work that the projects are doing. The projects are in different stages. Some of them are more starting, some are in the middle, and some are ending. But the idea of the cluster is that the projects come together to share their experiences and approaches and see how they can help each other to improve the system, safe system approach that we all share. Sorry that if we didn't reply to your questions, but you can always reach the speakers, and maybe we'll have a follow-up on that, and we will have more time for questions and hopefully good results as well. So with that, thanks to all the speakers, thanks to everyone who joined us, and hopefully we see each other soon. So thank you very much.
Thank you, Andrea. Thanks to all.
Thank you, Andrea, for
attending.
everything.
Bye-bye.
Thank you all.
Bye.
Thank you, Andrea.
Bye-bye.